Welcome back, Algebra 2. This is from Lesson 95, More Nonlinear Systems, focusing in on the fact that we are working with systems where one or both of these equations are not straight lines. I just put on here a chart for your reference of the different types of functions that you might be working with. There's nothing here that you're needing to memorize. It's just there as a reference tool. The last row here called the trigonometric functions, you can actually just ignore that. You're not going to be doing any sine, cosine, or tangent graphs at this time. Okay, so we're going to focus in right away on questions from your textbook. And you see that I enlarged this quite a bit. That's because these types of questions take up a bit of room. So if you find that you're running out of room, you're welcome to have extra paper or use margins on the side that you have not used yet. We're going to go to page 396 and write down what our system of equations is. It starts off 3x minus y equals 4, and then xy equals 7. Okay, so you should notice that the thing standing out, making this different than the ones we've done before, is we have an x times y. We have not done systems of equations where we're multiplying the x and the y together. So that is the unique part of our system of equations. Okay, so I'm going to ask that you go to the normal looking equation. That's the one up on top. And instead of focusing on the one that's different, let's focus on the one that is looking fairly normal and solve for y on that top equation. So rewrite it and get y by itself. You end up with y equals 3x minus 4. Okay, it's worth mentioning that Saxon often has you work with the uglier equation. He actually starts off by having you solve for y on the ugly one. That is absolutely a method you can use if you would like to follow along in the book that way. But I tend to find it's better for students to look at the easier equation and plug it in to the uglier one. So now that I have the easier one figured out and I have y equals 3x minus 4, I am going to plug it into that second equation. Okay, so in this case, instead of y, I'm plugging in, boy, this tool just does not want to work with me right now. I'm going to plug in 3x minus 4, all right, and then we still have the equals 7 on the outside. So that's the second equation with the first one substituted into it. I'm going to distribute the x across, so that part might look a little new for you, and I end up with 3x squared minus 4x equals 7. Okay, from here it is a quadratic. It has an x squared part of this function. So in quadratics we have learned that we are likely factoring or doing a quadratic formula, and that means everything needs to move to the left. So the 7 on the right hand side, we're going to subtract it to the left side. We get 3x squared minus 4x minus 7 equals 0. Then you have a couple choices. You actually have 3 choices, but most students do not like the third option. At this point, when we have quadratics, we've learned, and I'll put this off to the side, that you can factor, you can do the quadratic formula, or you can complete the square. And that last option is typically not our favorite. So if you are decent at factoring, please by all means go ahead and factor this equation. If you are not good at factoring, know that you can always do the quadratic formula and it will work. And in fact, you're going to see some of these equations Saxon purposely sets up, you cannot factor, you have to do the quadratic formula. Okay, so for this one, you could factor if you see it. I can do that very quickly with you to remind you how we do that. Factoring, we're going to look at the first coefficient, and I'm going to focus in on that 3. When I go to make my parentheses, okay, that 3x at the beginning, it's actually 3x squared, needs to break into a 3x times an x. Okay, and I can just randomly choose which ones I put those into. The second set is where it gets a little trickier. I have a -7. 7 can't not factor into anything besides 1 times 7, but we have to figure out which one goes where. Okay, so if I did start it off with just 1 times 7, I would notice that eventually I'm going to be multiplying 3x times 7, and that will not get me to a -4. It's going to get me too big. It's going to be 21. Okay, so I'm going to erase that, and I'm going to put, that must mean 7 goes in the first one and 1 goes in the second parentheses. All right, and then if I need to figure out which one's the plus and which one's the minus, well, you'll notice again that up here we have a -4x as our end result. So that means the larger number is going to be the negative. That's the 7, okay? So the 7 gets the minus, the 1 gets the positive. All right, now when I go back to solve all of this, each of those equations gets set equal to 0. And I lost part of my plus. There we go. So I have 3x minus 7 equals 0, and I have x plus 1 equals 0. And I solve each of those. This one I add the 7 over, and I divide by 3. And on this one I get x equals -1. I have 2x solutions. Now you've had some where that's happened, but the type of substituting back in here, this is where it gets a little bit tricky. So I'm going to go back up to my green equation, and I'm going to plug in my x values to that green equation, but I have to do it 2 separate times because I have 2 different x values. Okay, so when x equals 7/3, this is what that substitution would look like. Y equals 3 times 7/3 minus 4. Fortunately, it appears that I can just cancel out my 3's. That makes it a little bit prettier. So I end up with y equals 7 minus 4, or 3. Okay, so that was when x was 7/3, y was 3. I'm going to take that over here to the side and write it as a system of equations and make that one of my solutions. We are halfway there because we now have to go back and plug in our other x value, which was -1. So when x equals -1, this is what I get. Y equals 3, plug in -1, minus 4. 3 times -1 is -3. Subtract another 4, I end up with a -7. So this system of equations would look like this: -1, comma, -7. I'll go ahead and highlight that as my second solution. All right, this one is kind of an easy one compared to several others on this lesson, so stay tuned here. We're going to go through some more together. Going to question B. Okay. We have a little bit scarier system of equations. Starts off with x squared plus y squared equals 10, and then 3x squared minus y squared equals -2. All right, now you're not going to be quizzed on what this looks like, but I know I have some very visual students, so I'm just going to sketch for you off to the side what those two equations would do. The first one, I'll make a red graph for you. It is a circle, okay? It's just a circle. It happens to have the radius of square root 10. And the other one, let me just do a brown color here. The second one is actually a hyperbola. It's kind of like a parabola with a mirroring image to it. Okay, so you have two parts together that make a hyperbola. All right, now what I want you to notice is there are 1, 2, 3, 4 places of intersection. 4 different sets of intersection, which means we're going to have 4 solutions for this particular question. Okay, so heading back down to the equation, algebraically speaking, I'm zeroed in on the fact that I have a positive y squared and a negative y squared. I'm very excited to see that because I can just add straight down and those two things are going to cancel. So that's my first step, is adding straight down. Keep in mind that you have this silent 1 out in front of that first equation. Adding them together, I have 1x squared plus 3x squared. That's 4x squared. The y's cancel. On the right side, I have 8. Okay. Then I'm going to divide both sides by 4. I get x squared equals 2. And I am going to square root both sides. When I do that, I introduce a plus minus. I'll show it to you the way you've usually seen it. Okay, a plus minus root 2. But now I want you to think about that actually means 2 solutions. It means x is the square root 2, x is the negative square root 2. Now that I have those 2 solutions, I'm going to plug both of them in separate times to an original equation. I think I'll use the first equation. Okay, and I'm going to plug in x is square root 2. So on that first equation, I have square root of 2 being plugged in, squared plus y squared equals 10. Well, the square root and the squared do end up canceling, so it just becomes 2 plus y squared equals 10. Subtract the 2 over, and I have y squared equals 8. Square root both sides, I get a plus minus square root 8. And you should know by now square root 8 is not simplified. That turns into 2 root 2. So I end up with y equals plus or minus 2 root 2. How do I list that? I'll come back to that right equation in a moment. But how I show that system of equations for that left side, I'm actually going to pull it down here and show you. I have the square root 2, comma, positive 2 root 2. But I also have square root 2, comma, negative 2 root 2. Okay, so that drew from my 2 solutions here. So I have 2 answers out of the 4. Now I'm going to carry over to this right side, and I'm going to plug in a negative square root 2 to that same equation that I just plugged into. You should know pretty quickly that a negative being squared just becomes positive. So this ends up being 2 plus y squared equals 10, which looks a lot like what we just did. Y squared is 8, y is equal to plus minus the square root of 8, and further y equals plus minus 2 root 2. My solutions are very similar except for we had a negative out front. So when I go to write the solutions at the bottom for this pair, I have the negative square root 2, comma, 2 root 2, and the negative square root 2, comma, negative 2 root 2. That brings us to 4 total solutions. Okay? Now we're going to go into the actual homework assignment, and we're going to do question 6 together. Looking at my original equation, I have 4x minus y equals 3, and then I have xy equals 6. And as I stated at the beginning, I want to focus on the prettier of the 2 equations. I don't want the one that has x times y. Okay, so the first equation, I'm now going to rearrange it and solve for y. Okay, so for this one, I get y equals 4x minus 3. And then I take that and plug it in to the y on the second equation. So my second equation, rewritten, is x, plug in, 4x minus 3 equals 6. I distribute the x across, so that gives me 4x squared minus 3x equals 6. And remember, since we're dealing with a quadratic, that we move everything to the left, and that gives me 4x squared minus 3x minus 6 equals 0. You can be a factor king or queen, and you're not going to factor this, so you actually have to use the quadratic equation. Let me just put that down here for those students who need a refresher. X equals negative b plus or minus the square root b squared minus 4ac, all of that over 2a. Okay, so focusing on my a value, my b value, and my c value for this equation. And now I'm going to go back and solve for x using the quadratic equation. So I have x equals negative b value plus or minus the square root b squared minus 4ac all over 2a. Okay, so take a moment to get caught up there. We're going to simplify underneath the radical, outside, everything simplifies. Outside, a negative negative just becomes positive 3, plus or minus. Underneath that radical, I end up with 9 plus 96, so that actually comes out to square root 105. All of it over 8. I forgot to sub in my a, which was a 4. All right, square root 105 does not simplify. It stays as a radical 105. Okay, but now I want you to remember the plus minus component says there are two separate solutions. This actually means x is 3 plus square root 105 over 8, and x is 3 minus square root 105 over 8. So I have two separate solutions based on the fact that I had a plus minus. What's really scary is you're going to take those ugly answers and plug them back in to this y equals statement at the top. So I'm going to walk you through that. I have y equals 4x minus 3. And let's just plug in this first x value. That would bring me to y equals 4 times 3 plus 105 radical over 8, and then I still have a minus 3 outside. Okay, not much reprieve here, but we do get to reduce. 4 and 8 reduce to 1, and just a 2 in my denominator. Doesn't do much for me, but a little help. So that now is 3 plus root 105 all over 2, and I still have minus 3 here on the caboose. The minus 3 needs to be brought into that fraction, so I need to have a common denominator of 2. Okay, so I'm going to multiply by 2 over 2 to get that common denominator of 2. So the minus 3 times 2 is going to become a minus 6. And this is how that will play out. Y equals 3 plus square root 105 minus 6 all over 2. And then the 3 and the minus 6 combine into like terms. So I get y equals negative 3 plus square root 105 all over 2. Okay, that paired up, I'll do a yellow highlighter, that paired up with this first one. All right, now I have to go back and do the second one. I'll do a slightly darker green. You're going to see that when we sub in, it starts to take the same pattern, so you might be able to skip a couple steps. So we had y equals 4x minus 3. That means when I plug in, I have y equals 4, parentheses, 3 minus root 105 all over 8, minus 3. The 4 and 8 reduce, just like we did last time, to have just a 2 in your denominator. So I have 3 minus root 105 over 2, and a minus 3 outside. Once again, we multiply that by a 2 over 2 to get a common denominator. And I'll get simplified down to y equals 3 minus root 105 minus 6 all over 2. Final answer, or final step, I get y equals negative 3 minus 105 over 2. Use a different color highlighter for this one to pair it up. And these are my orange pair matching each other. Okay. That was for question 6. We are going to have 7. It's not quite as ugly. We're going to do that one later. I'll try to have that be something you guys can ask for help on, but I want you to try to do it on your own. As kind of a gift exchange with you, I'm going to go through question 5 and help you through that. Okay, so number 5 is the type of question that I have had a couple questions from you, some students. It is about the downstream and upstream chart. So we have Didia could row 60 miles downstream in 4 hours, but required 8 hours to row 72 miles upstream. What was her speed in still water? What was the speed of the current? We start this chart by putting our downstream and upstream titles. And remember that downstream is going with the current, so it's in a plus, boat plus current. Upstream, you're fighting against the current, so it's boat minus current. Then pull information from the question. 60 miles downstream took 4 hours. So my time is 4, my distance is 60. Okay, and then 8 hours were required to do the 72 miles upstream. So that's what my other row will look like. Just bring those down into a system of equations, but remember, parenthesize it if you're going to have to distribute. I'll try that again. A 4 or an 8 across, we have to use those parentheses. Okay, so we have B minus C. It's going to have the 8 distributed across on my next step. Okay, so first I just bring down those equations. Next I'm going to distribute. So I take 4 and distribute it back across the B plus C. And then the 8 gets distributed across the B minus C. I can use elimination on this. It might be a faster route. I see that I have a plus 4C and a minus 8C. I could just multiply that top equation by 2 and then bring it down here. So multiplying by 2, I would get 8B plus 8C equals 120. Then I'm going to go back and add those together. 8B plus 8B is 16B. The C's will cancel, and that is equal to 192. Divide both sides by 16, and I get B equals 12. Going back to refer to my question, it's asking for the boat speed, which is this, and we're using miles per hour. Okay, so I can fill that in. But I do also have to go back and find the current. So I'm going to use probably the very first equation that I created and plug in My boat is 12. And I need to figure out what my current is. Okay, I actually could have used it after I distributed. Either way is fine. So 4 times 12 plus 4 times C. And then I'm going to subtract that 48 to the other side. I get 4C equals 12. Divide both sides by 4. And I get the current is 3 miles per hour. So those are the two solutions for question 5. Good luck.